one machine. The cost of each job on each machine is given in the following table. The cost of each job on each machine is given in the following table. What job assignments will minimize the cost? Will minimize the cost. There are three jobs. So you have A, B, and C. There are four machines. So 1, 2, 3, and 4. So depending on this, our table entries that are given in the problem are your entries are 18, 8, 10, then you have 24, then you have 13, then 15, then you have 28, 17, 19, then you have 32, you have 19, and then 20. Okay. Now, the number of rows has to be increased by 1. The number of rows has to be increased by 1. Therefore, introduce a dummy row. The number of rows has to be increased by 1 because you have only 3 rows and 4 columns. Therefore, introduce a dummy row. So I am just altering it here only. I am introducing my dummy row. So when I introduce the dummy row, the cost that I have to give is all 0. Let me call this row as D. Now what I should do in my first solution from here, this is my first table. What will happen? From every row, I have to choose the smallest number and reduce it from all other numbers. So what will happen when I do this? I will have a 4 cross 4 matrix. So 1, 2, 3 and 4. I will be having a 4 cross 4 matrix. The smallest number in the first row is 18. 18 minus 18 is 0. 24 minus 18 is 6. 28 minus 18 is 10. Then 32 minus 18 is 14. 8 is the smallest in the second row. 8 minus 8 0. 13 minus 8 5. 17 minus 8 9. 19 minus 8 11. The third smallest element is 10. So 0. 15 minus 10 is 5. 19 minus 10 is 9. 22 minus 10 is 12. Here all the elements are 0, so we don't have anything to. Now since we have done this, you can very clearly see we are not able to allocate 1 0 from each row and each column so that we can proceed with our solution. So degeneracy occurs. So write down. Since degeneracy occurs, we cover, what should you do? Cover all the zeros by minimum number of straight lines. We cover all the zeros by minimum number of straight lines. So you can cover this and you can cover this. Now what should I do with respect to this? Look for the cells which are not under these dotted lines. Which is the smallest number in the cell 5. So take the 5, add the 5 to the point of intersection. So in my third one, this will be my third table now. So in my third table, I will have a 4 cross 4 table once again. So 1, 2, 3 and 4. We are going to have 4 cross 4 table. If you visualize the previous slide, 5 is the number smallest cell value which is available. So add 5 at the point of intersection. Here it is 5. All other remaining entries are all zeros. After you do this, subtract 5 from all other remaining cells. So you have a 0. You also have a 0. And then you have 9 minus 5 is 4. Again, 9 minus 5 is 4, 11 minus 5 is 6, 12 minus 5 is 7, then 6 minus 6, 0, 4 and 8. Even now, if you watch clearly, we are not able to allocate these two zeros because they are in the same lane. So again degeneracy occurs here. Again we have degeneracy occurring. So what should I do? I should again try to cover all the zeros with minimum number of lines. So let me try to
They have to subtract the first row of the 5
see, 5 is the smallest number which is there outside the dotted line. Okay, what I should do? Subtract 5 from all the numbers which are not in the dotted line. Wherever there is point of intersection, add 5. So this position, this fourth position over here, uh, this position alone you will add. Here you will add. Okay, add the 5. The remaining position you will leave blank along the dotted line. In all other open cells, that is without the cutting, you should subtract the 5.
Ma'am,
Okay.
then first row. 6 minus 1 is 1, ma'am.
6 minus 5 is 1. What did I do?
In the next table, it will be 6 minus 5.
Yes,
Zero,
I put
second
0.
column.
Okay, now it's alright.
Ma'am, the first row, third column is 5. 10 minus 5 is 5.
Wait, I think I have looked into some other table then. Just a minute, yeah, just a minute. Sorry. See, 5 is coming out, right? Wait a minute. 5 is there. 6 minus 5 is 1. 10 minus 5 is 5. 14 minus 5 is 9. So 14 minus 5, 9. 10 minus 5, 5. And then 5 minus 5. It's not 5 minus 5, it is 6 minus 5, so it is 1. And then here, these two places, it is 5 minus 5. Then 9 minus 5 is 4. 9 minus 5 is 4. 11 minus 5 is 6. 12 minus 5 is 7. Now, again, we are not able to map all zeros 1 1 uniquely in each column and each row. So, strike. How to strike? By minimum number of straight lines. So, we can choose 2 straight lines and 1 horizontal line. So, now we'll go on to the fourth table. When we go on to the fourth table, what are we going to have? So we are going to have another 4 cross 4 grid. Let us see what happens in this grid. So here we are having 4 cross 4. What is the smallest number which is outside? Value is 4. Add the 4 to this position. If I have to add the 4 to this position, 5 plus 4 is 9. 0 plus 4 is 4. In all other places, I should leave the lines as such. So I will have all zeros. And here also we will have all zeros. Then 5 minus 4 is 1, 4 minus 4 is 0, 7 minus 4 is 3, 6 minus 4 is 2, and 9 minus 4 is 5. Now see if you are able to mark 110 uniquely in each cell. Now if we need to mark uniquely, so here we can choose this 0. There is only 10 in this column, so we choose this 0. Then how
Ma'am,
is
it's called out.
um,
Ma'am, in the fourth step, the first row, second column, would it be 0 or 1?
it is 1. This 1 is there, no? This 1 is there. No. This 1 is there. Yes. I don't know what I'm leaving out that one. Right. So here also in the first row there is only 10, so we have to choose this 0. And then here you can choose, you have an alternate solution. Either you can choose like this or you can choose these two also. So now look at our mapping. ABCD to 1, 2, 3, 4 is the mapping. So we have A, B, C, D, and then we have 1, 2, 3, and 4. So we have A goes to 1, we have B goes to 2, C goes to 3, and we have D goes to 4. Now give me the value. Your optimum minimum cost would be, therefore, my optimum cost will be equal to I have to look into the original table. The original table is here in my first slide. So 18 plus 13 plus 19 plus 0. Am I correct? 18 plus 13 plus 19 plus 0. Check and tell me what value you get. 9 plus 3, 12 plus 8, 20 carry over to rupees 50. So minimum cost is rupees 50. Everybody is getting this?
Ma'am, I have a doubt.
Ah.
Ma'am, the third table, first or second element. How does that become
How does it become?
one?
Where? Tell me once again. Third row.
Ma'am, in the third table, first row, second element.
Come here. You have 6 here. No, you are subtracting 5 from every number. No, 6 minus 5 is 1. Here only, right?
Okay.
Ah.
Okay, ma'am.
Okay. Right. Now there is an alternate solution. So what is the alternative? The alternative is I can choose this 0 and I can choose this 0. So I will have my A goes to 1, my B goes to 3, my C goes to 2, and my D goes to 4. So suppose I am going for the other solution. What happens to my optimal cost? My first value here is not changing, so it is 18. The last value is not changing, so it is 0. B goes to 3. What is 3? 3 is 17. So B goes to 3. And your C goes to 2. C goes to 2 is, I think, 18. Check. Where is this? C goes to 2 is 15. So 17 and 15. So here I will have 15. Again, 8 plus 7, 15 plus 5, 20 carry over 3. So whichever choice you make, either you choose all these zeros which I marked in red, or you have chosen the first and the last. This is also common for the black one. This is also common for the black one, and these two you are choosing. You find that there is no change in the optimal cost. So you need not worry. If you can identify, you should identify all possible solutions, but the optimal cost will not change. It will be the same. Okay. So everybody understands now what is an unbalanced transportation problem and how you can resolve your degeneracy. And there are problems where you have alternate solutions. Okay. Next, maximization problem. Take the heading as maximization problem. Okay. So what you should do in maximization? Same as your transportation, take the largest number, subtract it from all other cell values and proceed as usual.
Excuse me, ma'am.
Ah.
Not audible.
How do you okay? Now? Now? Wait here.
Now it's fine. Now.
Okay, I need to face the system. Right. So how do we solve a maximization? We take the largest cell value, subtract all other cell values from this, and then proceed as usual to obtain the solution. So take down maximization problem. The conversion of the maximization problem, the conversion of the maximization problem into an equivalent minimization problem into an equivalent minimization problem can be done by any one of the following methods. Can be done by any one of the following methods. Number 1. Since maximize z equal to minus minimum minus z multiply all the cost elements, multiply all the cost elements Cij by minus 1. This is one way of doing, but which we normally don't follow. Number 2, subtract all the cost elements, subtract all the cost elements Cij, subtract all the cost elements Cij of the cost matrix from the highest cost element from the highest cost element in the cost matrix. So this is what we are going to do. We then proceed to solve using the usual Hungarian method. We then proceed to solve using the usual Hungarian method. Okay, right. Once you finish, you please tell me. We will do one problem based on this. Okay. Shall I dictate the sum? Yes, ma'am. Shall I dictate the problem? A company has a team of 4 salesmen. A company has a team of 4 salesmen, and there are 4 districts. A company has a team of 4 salesmen, and there are 4 districts, where the company wants to start business. Where the company wants to start business. The profit per day in rupees for each salesman, the profit per day in rupees for each salesman in each district is as given below. So please take down. Okay. So we have A, B, C, D, 1, 2, 3, 4. We have A, B, C, D, 1, 2, 3, and what will be what here? Which is salesman, which is district now? District is on top or side?
Top.
Yes. District is on top. Salesman is by the side. So there are 4 salesmen who need to go to the 4 districts. Okay. So you have 10, you have 11, you have 15, you have, then you have 14, 15, you have 13, 14, 11, 15, 12, and 15. So these are the entries that you have got. 4 salesmen and 4 districts. Find the assignment of the salesman. Find the assignment of the salesman to various districts. Find the assignment of the salesman to various districts which will yield maximum profit. Which will yield maximum profit. Okay, so write down solution. What should I write? Is it balanced or not? Yeah.
Balance.
Yes. So salesman equal to district. The number of salesmen equal to number of districts. Therefore, it is a balanced problem. Therefore, it is a balanced problem. Then, what else? It is a maximization problem. It is a maximization problem. Therefore, what is the highest cost Celia? Therefore, highest Cij, what is this value? 16. Highest Cij equal to 16. Subtract all other entries from 16. Subtract all other entries. Subtract all other entries from 16. So when I subtract all the other entries from 16, what will I get? I will have a new table. I'm going to have a 4 cross 4 table. So 1, 2, 3 and 4. I'll have 1, 2, 3 and now we are going to have 16 minus 16 0. Then 16 minus 14 is 2. 16 minus 15 is 1. 16 minus 13 is 3. Then 4. Then 2. Then 3. If I make a mistake, 3 or 1? 1. If I make a mistake, tell me, I am reading from the side slide. 16 minus 10 is 6. Then I'll have 2. And then I will have 5. Then 16 minus 11 is 5. 16 minus 15 is 1. 16 minus 15 is 1. Then 16 minus what I have here 15, 13, 12. 15, 13. Check if you're getting same entries here.
Same.
Same. So now what we have to do, from every row subtract the smallest element from all other elements. We have to proceed as per that. So write down step 1. Subtract the smallest element from all other elements from the corresponding rows. So first row 0 is there. So it will be 0, 6, 2, 5, no change. Second row 1 is the smallest. 2 minus 1 is 1. 5 minus 1 is 4. 1 minus 1 is 0. Then again 1 minus 1 is 0 here. Then 3 minus 1 is 2. 4 minus 1 is 3. Come for the last row. 3 minus 1 is 2. 3, 1 and 0. Now you see every column there is a 0, but still degeneracy is not resolved. Or is it resolved? Is it resolved or is it not resolved? Oh, what is this? Try to allocate 110 from each cell here. See, I can choose there is only 10, so I choose this. There is only 10, so I choose this. There is only 10 in this column and there is only 10 in this column. Therefore, we are able to allocate. So, what is our allocation? We have our A, B, C, D. We have 1, 2, 3 and 4. So, what is the allocation that we have given for us? A goes to 1, B goes to 3, C goes to 2, and I have D goes to 4. Therefore, the total minimum or maximum, yeah? What should I write? Ah, yes. So how should I write? I should not use the word total. Rather, I should use the maximum profit equal to. Therefore, maximum profit equal to. How you should read, you should look at these cells in the first given table. This is given in the question. No, you should read the value from the question itself before you subtract. So what will be the value? 16. So the first cell, first entry is 16. Second row, third entry. Second row, third entry is 15. Third row, second entry. I think that is also 15. Third row, fourth entry. I think that is also 15. 15. So you will have rupees. Therefore, the maximum profit is rupees 61. Any problem for anybody? Everybody is able to follow? Is there any alternate solution in this sum?
Yes, ma'am, we have zeros in the third and second row.
You cannot change. Who will change? There is no alternate solution. The reason is, if you choose this 0, it will bang with the 0 in A and first row has only this 0. Therefore, you cannot alternate. You cannot choose this first 0 in C because it goes with A. Similarly, you cannot choose the fourth 0 because in D row, there is only one 0. So, there is no alternate solution. How you have to select your zeros? It should be 1 per column as well as 1 per each row. Therefore, this particular problem does not have any alternate solution.
Okay, ma'am. Ma'am,
Hmm.
ma'am, my note is in the question, like we're supposed to minimize how much, like minimize the cost of the salesman.
You read the question here. What was the last line? Find the assignment of the salesman to various districts which will yield maximum profit. You want to minimize profit and go on loss, huh? What is wrong with you?
Oh, no, ma'am, no, ma'am.
Hmm.
So what I thought is like, it's about the salaries, like, about the payment.
Okay. Right. So this is an example of a maximization problem. Fine. So now we know to do also maximization under assignment. The last type of problem in assignment. What is that problem? Sitting down. Restrictions in assignment. So what we mean by saying restrictions in assignment problem. Okay. So we will look into that. Restrictions in assignment. Can anybody guess? Can anybody guess what this would be? Now what we did, we said one person, one job. That's all. Any job can be done by any person. Suppose one person is not capable of doing one particular job. You are not able to assign a particular job to a particular machine. So that is also possible in real time. So when that happens, how to go about it? Actually, when that happens in an assignment problem, the simplest thing is to make your cost very high so that you don't choose the cost for minimum value. So we will make the cost as infinity. So take down the assignment technique. I am dictating, I am not writing. Okay. The assignment technique assumes that the problem is free from practical restriction. Assumes that the problem is free from practical restrictions and any task could be assigned to any facility. Any task could be assigned to any facility. But it may not be possible in all cases. This may be overcome by assigning a very huge or high processing time assigning a very huge or high processing time or cost. I'm repeating, the assignment technique assumes that the problem is free from practical restrictions and any task could be assigned to any facility, but it may not be possible, but it may not be possible in all cases. This may be overcome by assigning a very high processing time or cost. Within brackets you write infinity to the corresponding cell. This cell will be excluded. This cell will be excluded in the assignment. Okay, this cell will be excluded in the assignment because of the unused high time cost associated with it. Unused high time cost associated with it. Okay. So we'll see how to go about this by means of a very small sum. Take up a machine shop purchased a drilling machine and two lathes, a drilling machine and two lathes of different capacities. The positioning of the machines among four possible locations on the shop floor. The positioning of the machines among four possible locations on the shop floor is important from the standard of materials handling. We'll stop. Given the cost estimate per unit time of materials below, determine the optimal location of the machines. Determine the optimal location of the machines. Okay. So we are going to have zeros.
Ma'am, could you repeat the question?
Question. Right. You stop me wherever you want. Okay. A machine shop purchased a drilling machine and two lathes of different capacities. The positioning of the machines among four possible locations on the shop floor is important from the standard of materials handling given the cost estimate per unit time of materials below, comma, determine the optimal location of the machines. Determine the optimal location of the machines. Okay, so this is your tabular column. You have 4 locations, 1, 2, 3 and 4, and you have 3 options. The values are 12, 15, 4, 9, then you have not suitable, then you have 8, you have 12, you have 13, then you have 10, then you have 9, 20 and 6. Okay, now please look. What is not suitable? The drilling machine is not suitable for the second location. So you have to make it as infinity. So write down solution. Solution. The drilling machine is not suitable for the second location. Therefore, assign it or assign the cost element a huge value, say infinity. Now, is the problem balanced or not? What, yes or no? No. So, what should I add? Column or row? Row. Right. Make it into a balanced problem. Make it into a balanced problem by adding a dummy row. Make it into a balanced problem by adding a dummy row. Therefore, we'll go to a new slide itself. Therefore, the assignment table becomes what happens? You have 4 rows. You are going to have 4 columns. Can anybody call out entry for me? 12, 9, 12, 9. First row, 12, 9, 12, 9. Then, what is the second row, yeah? Second row is
15, 320.
15, infinity, 13.
30,
30, 20. Then my third row,
4, 8, 10, 6.
okay. 4, 8, 10 and 6. The last is dummy, so all the values are zeros. So from every row, we take the smallest element and then subtract it from all other elements in that particular row. Let us try doing it. Because there is no point in doing it for the column because the last row is all zeros. So from every row, smallest element in the first row is 9. So you will have 3, 0, 3, 0. Come for the second row, value is 13, 2 infinity, 0, 7. The third row, value is 4, 0, 4, 6, 2. Last row, values are all zeros. Now how to pick on the 0? In every row, if there is only one single 0, first circle those. So here in my second row, there is only 1 0. In my third row, there is only 1 0. So I have chosen these 2 zeros. Now, I want to choose a 0 from the first and the fourth row. I can choose this 0 here and I can choose this 0 here. Alternately, what I can do is, here I have to choose this 0 only because there is only 1 0. But in this position I can choose this, and so there exists an alternate solution plus you are having this solution. So what would be the optimal allocation? So my allocations are, what happens to my allocations? I have A, B, C, D, 1, 2, 3, 4 I suppose. No, I am having what here? lathe, drill, lathe. So let us have this as L1, T, L2. Let us call this as L3. So I will have my L1 goes to 2, my so what will I have over here? My L1 goes to 2, then my D goes to 3, my L2 goes to 1, and my L3 will go to 4. Now look at the values. I have taken only the purple count. So for the purple count, I have to add. So the optimum value. So the optimum value equal to the first entry in the question. What is the first entry in the question is 12. I'm sorry, I got L1 goes to 2. So this value is going to be 9 for us. So this is going to be 9 plus the second row goes to 3. So it is 13. L2 goes to 1. So it is 4. And L3 value is 0. So 13 plus 13 value is 26. So the answer you get is 26. Suppose you take the red ones. Okay, suppose I take the red ones. I'm writing by this sign. Suppose I take the red ones, then my allocation will be, what will be my allocation? L1 goes to 4, then I will have T goes to 3, I will have T goes to 3, L2 goes to 1, and I will have L3 goes to 2. So anyway, this is 0. L1 goes to 4, so it is 9. And then my B goes to 3, so it is 13. My L2 goes to 1, value equal to 4. Again, the value is equal to 26. So the optimum value is the same, whichever allocation you take. This is your allocations for your purple marking, and the second one is the allocation for your red marking. So whichever you take, you find that you get the same. Is it okay? People are able to follow?
Yes, ma'am.
So to summarize what we did today, we had an assignment problem. We went to further to see what is an unbalanced assignment problem, and then we did maximization of allocation assignment problems with degeneracy, and finally we saw restricted assignment problems. So with this, we are happily finishing this unit. Okay, so we'll take attendance now. All this more than your transportation. No, your assignment problem. These all kudi some small sums. We can ask for 3 markers. We can even ask you to. We can give you solutions and say choose the correct solution and for 3 marks. So these things you can do. Just 2 tables and you get your answer, your optimal value. So probability of you getting assignment sums for 3 marks and 2 marks is more. Okay. What is today's date? 9th. 9th. Okay. Please answer attendance, ma. Yes, those who give me attendance can leave and go and join the lab. So register number 1 is there.
Yes, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present.
5. 5 is not there. 6. 5 is present. 6. 7 is present. 8.
Present.
9.
Ma'am, 8 also present, ma'am.
Yes, ma. 9.
9 present, ma'am.
10.
Present, ma'am.
11.
Present, ma'am.
12. 13. Present. 14. 15. 1, 5. 15 not there. 16. 17. 18. 18 please. 19. 20. 20 present 21. 22 present 23. 24. 24. 24 is present 25. Present 26. 27. 28. Ah, yes. Okay. 29. 29. No. 30 is present. 31.
22 present, ma'am.
33.
33 present, ma'am.
34. 35.
Present, ma'am.
36 is present. 37. Present. 38. 39. 40. 41. 41. 42. 42. Present. 43. 44. 45. 46. 47. 47, please. Okay. 48. 49. 50. 51. 51. No. 52 present. 53. 54. 55. 56. 56, yeah. 57. Yes, present. 58. 59. 60. 61. 62. 63. Then 108. Okay, 108. Today's absentees are 47 and 56. Okay, thank you. So please install your what is that add-in. We will see in day after tomorrow's class. Day after tomorrow's first 2 hours practical session. So everybody should be present with your laptop. Okay, either you should have original Windows or cracked version. Then only it runs. If it is a home office which is given to you along with your purchase of the laptop, then we are not able to install this add-in. What happened? If you see, I would have given personal comment also. See, Z value you should write. You would have missed out on writing the Z value separately. That is one factor. The other thing is, suppose the graph clarity is not there with all the feasible points marked properly. That is one factor. The other thing is, you people have not shown your solutions. So that is one factor. Of the 3, any one criteria you would have fallen into. Okay. So all of you check, both your marks are uploaded, your CT marks as well as your practical marks. From next time onwards, practical will be practical. Within the time, you should actually post your report to me that you get in your Excel after doing the add-in procedure. Okay, thank you. Who is present? 56 present. Okay, when did 56 join? You texted me. Okay. Fine. You texted me only now, 2:14. Only 47 is absent. Okay, thank you.